Hello students, today we are going to study directly from book to mind. So we are doing book study and I hope you will find it helpful. So pituitary hormones, hypothalamic releasing factors and drug affecting uterus. So what are pituitary hormones? And all this we are going to know. So endocrinology involves understanding of hormone secretion, hormone actions and their feedback control mechanism and treatment of endocrine disorders. The endocrine means एंडोक्राइनोलॉजी का काम है हार्मोन को सिक्रीशन करना, हार्मोन के एक्शंस करना और उनके फीडबैक कंट्रोल मैकेनिज्म को अंडरस्टैंड करना एंड ट्रीटमेंट किया एंडोक्राइन डिसऑर्डर्स का. एंडोक्राइन का डिफ्रेंशिएट करता है द एक्शंस ऑफ हार्मोन सिक्रेटेड मेनली इंटरनली एंड एक्सटर्नली. अगर से इंटरनली देयर इज अ हार्मोन सिक्रेशन, सो इंसुलिन फ्रॉम द पैनक्रियास लाइक इंटरनली and externally exocrine pancreas like pancreatin pancreolipase enzymes from the pancreas. Hormones are chemical substance. If it is secreted from insulin, pancreas is secreting insulin, okay, that is internal. And exocrine means enzyme from the pancreas. Both are being secreted, but external secretion or internally secretion, there is a difference. Hormones are chemical substances which are synthesized by specific endogenous glands and secreted internally directly into the bloodstream. When directly into the bloodstream, that are hormones to act far away from the site of their production and release on the specific target tissue या organs. Okay, so that's why they are taken by blood. This definition does not include non-hormonal substance like glucose, though it is synthesized and secreted by the liver. Glucose being taken away from main source, it is non-hormonal substance, okay, and secreted and synthesized from the liver like gluconeogenesis. Okay, so this definition is not for glucose. And autocoids which are synthesized in specific tissue and released locally to act at the site of their release. Okay, so autocoids are being synthesized. Okay, and wherever the site is, they are acting at that tissue only and locally only. Okay, histamine, bradykinin and prostaglandin. But when the glucose which is non-hormonal being synthesized by the liver in gluconeogenesis but has been taken to other places. So that is the difference with this hormone definition. With non-hormonal like glucose and like hormonal, but they are acting at the autocoids, like acting at particular place only. Okay, so histamine, bradykinin and prostaglandins. Chemically, hormones can be divided into 7 major classes. Okay, one is amino acid derivative when it's derived from amino acid. Neuropeptides, simple proteins, large proteins, glycoproteins, steroids and vitamins. And some new hormones also, inhibin, ghrelin and leptin. Okay, so when it is amino acid derivative such as dopamine, catecholamines and thyroid hormones. Neuropeptides such as gonadotropin releasing hormone, thyrotropin releasing hormone, that is TRH, GnRH and somatostatin. They are neuropeptides. Generally they are being secreted, GnRH, gonadotropin releasing hormone, from the hypothalamus. Okay, all the releasing hormone are being released, and like TRH, thyrotropin releasing hormone. Okay, GnRH, TRH and somatostatin. Somatostatin from the pancreas. Okay, in pancreas there is 3 kind of cells. From one of them, somatostatin is being released. Simple proteins like corticotropin, large proteins, insulin, luteinizing hormones and parathyroid hormones. Glycoproteins like thyroid stimulating hormone and steroids like cortisol, estrogen, progesterone and glucocorticoids. Vitamins, vitamin D. Some newly discovered hormones such as inhibin, ghrelin and leptin have also been become part of the medical science. So now we are coming to functions of hormones. Subsequent chapters describe the details of the functions of different hormones. However, the physiological functions of the hormones in totality can be divided into three major areas: growth, differentiation, maintenance of homeostasis, and reproduction. These are the three major areas which are related to hormones. Hormones function: growth, differentiation, maintenance of homeostasis, and reproduction. Growth and differentiation. Many hormones play a vital role in the complex phenomena of growth and development of secondary sexual characteristics. For example, short stature may be caused by the growth hormone deficiency. If there is a deficiency of growth hormones, short stature is happening. Or due to hypothyroidism, while the development of secondary sexual characteristics takes place under the influence of ovarian and testicular hormones. Because of the hypothyroidism, there may be the short stature. Why is hypothyroidism? While the development of secondary sexual characteristics, the influence of ovarian and testicular hormone. Ovarian hormones is like estrogen and testicular like testosterone. So both deficiencies causing short stature. Maintenance of homeostasis. Though virtually all the hormones affects homeostasis, the most important among them are regulation of glucose level by insulin. It balances the homeostasis. Regulation of sodium and potassium concentration by aldosterone. Regulation of calcium and phosphorus levels by the parathyroid gland, parathyroid hormone, and regulation of serum osmolality by vasopressin. So what is homeostasis? It is a balance. So these are insulin, sodium and potassium concentration by aldosterone, calcium and phosphorus by parathyroid hormone, and serum osmolality by vasopressin. These are all maintaining. Reproduction function integration. The stages of reproduction include sex determination during fetal development. This is the stage of reproduction. During the fetus development, sex determination. Sexual maturity during puberty. Conception, pregnancy, lactation, maternal behavior. Ultimately, cessation of reproductive capability at menopause, females, or old age males. All stages involves an interplay of sex hormones. We will study in other chapters also. In addition to sex hormone, prolactin is involved in lactation and oxytocin, mediates the suckling response and release by oxytocin, suckling and ejection of milk. Now we are coming to hormones, receptors and mechanism of hormone actions. So receptors of hormones are divided into three major classes. One is membrane receptors, which is primarily bind neuropeptide hormones and catecholamines. Other is membrane receptors are of several types. Okay. Membrane receptor is for neuropeptide and catecholamine. So GPCR, G protein coupled receptors, working through the adrenalis CMP system. Epinephrine, dopamine, TSH, FSH, TLH, PTH and ACTH all work through this GPCR or through the phospholipase C-anositol system. Or oxytocin, vasopressin. As for phospholipase cortisol is for oxytocin, vasopressin. Then tyrosine kinase receptors, like for insulin, growth hormone and growth factors. First we have studied GPCR. Second we are studying tyrosine kinase receptors. Third we are studying cytokine receptors. And fourth is serine kinin receptors. These are four kind of membrane receptors. GPCR is working through adenylate cyclic AMP system. These are all related, and or through phospho-C-anositol system. So oxytocin and vasopressin related. In tyrosine kinase, insulin or growth hormone and growth factors related. Cytokine receptors as for prolactin and some growth factors. Serine kinase receptor as for activin, transforming growth factor beta, and bone morphogenic proteins. Other one we have, all these are membrane receptors. Now cytosolic receptors are for steroidal hormones such as glucocorticoids, mineralocorticoids, estrogens, progestins, and androgens. They are at the cytosol level. Nuclear receptors are for thyroid hormones T3, T4. Receptor numbers for hormones vary greatly in different target tissues. For example, ACTH receptors, which is what? GPCR, are located almost exclusively in the adrenal cortex because it is adrenocorticotrophic hormone, ACTH, exclusively at the adrenal cortex, and FSH receptors are found exclusively in the gonads. The function of the ACTH is from the adrenal cortex only, and FSH from the gonads only. So there are these receptors particularly located. And contrarily, insulin and thyroid receptors are widely distributed, reflecting the need for hormone-induced metabolic response in all the organs. They are everywhere, insulin and thyroid receptors. So, hormone-induced metabolic response in all organs by this thyroid and insulin. Next, we will study the hypothalamic pituitary relationship in other series.